Hello all. So our next force is the weak force. Weak force. So this weak force is actually stronger than the gravitational force. Where we observe this force, we found that during beta decay, see, a neutron when gets converted into a proton plus an electron plus an anti-neutrino. This is anti-neutrino, the anti-particle of the neutrino. So see, this neutron is neutral, this proton is positive, electron is negative. So earlier we have studied the conservation laws. In the conservation laws, I told you that these in any reaction, in any phenomena that happens in this nature, these conservation laws must hold. So our first law, our one law was the conservation of mass. So mass of neutron is equal to the mass of proton, or the mass of proton plus electron. The mass of electron is negligible. This anti-neutrino, this has zero rest mass, so the mass is conserved. If we'll see that even if the anti-neutrino is not written, even then the mass is conserved. Our next is the conservation of charge. This is neutral and this is positive, negative. Again, total charge is zero, so the charge is also conserved. In spite of that, we are writing here anti-neutrino. So this was because we found that in the beta decay, we found that the electrons or the beta particles which were evolved, they were having different energies. All the beta particles, they were having different energies. So to explain that difference, to explain that variation in the energy of the beta particle, the theory of weak forces was given that there is a particle which is also evolved during this beta decay, and that particle is the anti-neutrino. And this is having zero rest mass, no charge, but this interacts with the electron. So and that interaction of electron with the anti-neutrino during the beta decay is through the weak force. This is where the weak force acts. The interaction between electron and anti-neutrino. Why? To explain the variation in energy of beta particle is this interaction is through weak force. But this weak force is not the weakest force. This is a weak force, not the weakest force. The weakest force in nature is the force of gravitation. This force is 10 raised to power 26 times greater than the gravitational force. And this force, this weak force is not a central force. As we earlier we said that the gravitational force acting between two bodies act along the line joining the two particles, but this weak force, this does not act but along the line, this does not act along the line joining the two particles. So if this is electron and this is the antineutrino, so it is not acting along the line, so this is not a central force. And because this is not a central force, for the same reason this is also not a conservative force. Unlike gravitational force. Unlike gravitational force, this is neither a central force nor is this a conservative force. Also, this is not a long range force. And again, this is again a non-contact force. So how this force is being applied, how this force applies? This force is again applied through the field. This is again applied through the field, and the field particle, as was in the case of gravitational field which I have earlier discussed, the field particle is neutrino. So there is continuous exchange of neutrino between electron and antineutrino during the beta decay. That is why that is how we explain the variation in the energies of the beta particle which are evolved during the beta decay. And this is all about the weak force. And yes, that this is not the weakest force, this is 10 raised to power 26 times greater than the gravitational force. So this was the second force which we have discussed earlier. We have discussed the gravitational force in detail in the previous video, and please check out that video as well if you have not. So thank you very much for watching this video.